welcome to How to Repair. In this video on Beko Tumble Dryer, we have done other videos that you can find on our YouTube channel or our website on how to replace the belt, how to test the capacitor, how to service and maintain the machine, plus many other videos which we've done on tumble dryers in the past, especially the new ones with electronic relays on the circuit board that control the heaters, which can also become faulty. But I'll explain this later in the video. The first thing we need to test is the heating element at the rear of the machine. This has a thermostat and a NTC sensor. On the front of the machine, this machine has an NTC sensor which we'll test, and then I'll show you the relays on the circuit board. So the first thing we need to do is remove the rear cover on the machine. This will expose the heating system. Just undo the screws all the way round. Once the cover is, all the screws are taken off the cover, sometimes you may need to put a flathead screwdriver just to prise the seal away, but the cover can be removed. Here we have the heating element and also an NTC sensor and a thermostat. Right, so first let's check the heating element. Now we have 5 wires coming in. Behind here is a terminal block which you can disconnect, which is a good idea. This will disconnect all of these 5 wires. There's 2 blocks which I'll show you in a second. I'm not going to take the whole back of the machine off because you can see this in another video, how to remove the back panel, on the maintenance video, which I'll put the link below. Then we have a cycling thermostat. This is normally, I believe, a 63 on vented tumble dryers, 63 degrees it cuts in and cuts out, and this top one is an NTC thermostat or sensor. So I'm going to disconnect the wires so we can test the 2 sides of the element, because you have a high side and a low side. The high side is about 1400 watts and the low side is about 600. So I'm undoing the 2 plugs. Now the 2 plugs have got notches in, which mean that they can only go in one way. Right, the first thing we're going to do is, now we've disconnected the electrical block, is test the element. And let me explain all of this first. You have 3 wires. One is going, a blue wire is going to the cycling thermostat and then back down to the element. This element then connects with the black and the white. One is the high side, one is the low side, because the element has a high heat and a low heat. The 2 red wires are going to the NTC sensor. So the first thing we want to do is actually make sure the element is good. Now we can do that just with normal continuity. Go from the blue wire to the black wire, we should have continuity, and blue wire to the white wire, we should have continuity. But we can actually use Ohm's law calculator, which is available to you on Google free of charge, and you'll be able to put the voltage of the appliance in, whatever you're working on, and work out what the ohms resistance should be in wattage terms. So by going from the blue wire to the black wire, we have an ohms resistance of about 40, and that should give us somewhere in the region of 1300 watts, depending if the meter is calibrated the age of the element. But going from the blue wire to the white wire, we have a reading of 95, which gives us a reading of about 600 watts. So the combined wattage of the element is 2 kilowatt, which is about correct. Now, the next thing we need to test is the thermostat. Now, I could take the wires off, but as I've disconnected the block completely, if I test from with continuity this time, if I test from the blue intake coming in to the blue on the meter, meaning it's going through the thermostat, we should have continuity because the thermostat is cold and it hasn't got to temperature, therefore it should have continuity. And as you can see, we've got continuity going through this thermostat. That means the cycling thermostat is good. Next, it's a little bit more complicated. These are, although they look like thermostats, they're not. They're NTC sensors. I'll put a link in the video below the description on how NTC sensors work and how to test them. But basically, the manufacturer states that this NTC sensor should be in the region of 19.5 ohms at 25 degrees. Now our temperature is about 17 degrees in this room at the moment. So we'll turn it to ohms and we'll go across the two terminals, and as you can see we've got 26, but the wiring can affect these slightly, so I'm just going to pull the two wires off. I'm going to put my croc clips on and I'm going to put one on one side, one on the other side. Now I'm just going to warm up my fingers, and as you can see I've got 26.28 resistance, but if I touch the NTC sensor you will see the ohms resistance dropping, and if we got this up to 25 degrees we should have a reading of about 19.5. Remembering that your meter needs to be calibrated on a yearly basis for it to be very accurate, but I'm happy that this NTC sensor is within the boundaries of what it should be and is working correctly. So I'm going to put all this back together, connect up the motor harness, and as I said, the motor harness has lugs. If you need to get at the other side of this, you can see our maintenance video on these Beko tumble dryers, and it will show you how to take the whole back off the machine and service the machine. It is quite important because, as you can see, even around this heater here there is fluff build-up, and this, in my opinion, if it is not dealt with on a regular basis, is a slight danger to machines because the fluff can get very hot and can combust. So it's well worth servicing the machine. Have a look at our maintenance video and how to hoover out the whole machine and get rid of all the dust. But I'm just going to connect all this back up and then we'll look at the forward NTC sensor and check that that's within its boundaries. Then we'll look at the circuit board to possibilities that a relay has gone faulty, which is easily changeable. There's another video on the website about tumble dryer relays, and I'll show you that later in the video. While I'm assembling all this, I'm going to show you a diagram of the wiring diagram on this tumble dryer. For those of you who are familiar with wiring diagrams, it will help you understand the circuit. And as I said earlier, it is well worth, if you've got an intermittent problem, chasing the wires from the plug here all the way back to the circuit board, and make sure you have no metal fatigue or any wires that have been chafed or broken going to the circuit board. So if the circuit board is sending voltage to the heater but the wire is broken, that may be a reason why it's not heating. So we've replaced the back. Next thing we need to do is have a look behind the facial panel for the NTC sensor. To get access to this we need to take the lid off. So we'll just undo the 3 screws at the back. The lid comes back, lifts up. That can go out of the way. I'll turn the machine around for you. There are 3 screws at the top holding the facial panel. The facial panel will just come up slightly. You will have to unclip some wiring. Now this can come away. We'll need to unclip some wiring. And these 2 wires here on what goes to the NTC sensor. This NTC sensor measures the airflow inside the drum, and the circuit board then works out what the temperature is and how much heat is required. So again, I'll put my meter in eyesight for you, set it to ohms. Now I can't warm this NTC sensor up without having the whole drum, but as you can see, this NTC sensor, according to the manufacturer, is the same as the one on the back. So it's 19.5 at 25 degrees. Of course, this is very close to metal and it's a cool item. The air may be a bit cooler inside, and that's why it's reading 27. So after taking the measurement on the rear one, where it is exposed to more ambient air, I'm happy with this NTC sensor. That is reading the correct value. So our heating circuit, if you have checked the 3 wires which I was talking to you earlier about, the grey, which is that one, the green and the orange, which went to the heater, you can check that you've got continuity all the way through the wiring loom to the heater. Then there is a high possibility that the circuit board may have a faulty relay, and in this modern age of relays and circuit boards, they do go faulty after a period of time. So what we need to do is expose the circuit board to have a look at the relays. Now I'm going to take some photographs of the wiring, and then we'll start unplugging all the connections and remove the circuit board from the actual plastic mounting. I'm just making sure I've got all of these photographed where they're going to. As I said, a lot of these plugs do have one-way connectors. They can only go in one way. So first thing we'll do, the brown and the blue come from the filter, electrical filter at the back. Then we have the other 2 wires. You can also test the on-off switch. One side is the neutral, the other side is the live, and when you press it in you should have continuity across both of these. Now we're going to undo this double white. That, I believe, goes down to the humidity reader, which is the 2 bars in the drum. You can find out all about that in another video that I've done on servicing and maintenance on these Beko tumble dryers. Do be careful with these. Sometimes they are difficult to get out, but don't pull hard on the wiring. And as I said, all of these plugs normally can only go in one way. And that's our board ready to come apart. So I'm going to show you how to take this board out. You can see there are some screws which need to be undone. We'll undo this plug as well, because the board might come out without me taking this end piece off. Right, using a small flat blade screwdriver, you can see some plastic lugs which need to be pressed as you lift the board up. They're quite tricky, so this one needs to come up. Then we can get this one from this side, and then the next one, and the next one, and that board comes away. Now when reinserting it, it's very important that you get the knob on the front is a D shape. So you need to make sure that that is correct. So now we've got the circuit board. We need to open the circuit board up. Now again, you can see that there are some tabs that need to be pressed down. So we'll start on this side, pressing that one down first. This plastic can be a little bit brittle, so do just take your time. Now we'll go to the other side. And there we go. Okay, as you can see, quite a bit of dust built up on the circuit board, but we have 1, 2, 3, 4 relays. Now what you have to ascertain is where these relays are going. Working the wiring out is sometimes the most confusing. On the heater plug coming out of the plug going to the element, we had 3 coloured wires, blue, black and white. But the wires going to the back of that heater plug were a different colour, and they were actually grey, orange and green. So the grey wire goes to this relay, and the orange and the green wires, I believe, are on those 2 plugs, and they look like they're going to this relay. So it could be one of those 2 relays, or possibly this relay, that it is at fault. And without taking the relays out, it is impossible to test them. But once you have got the relays out, if you have the right voltage to activate the relays, you'll be able to do continuity readings on the relay. But you're going to have to watch this in another video. What you need to Google is tumble dryer relays, and I've done a video on how the relays work and how to test them, and also how to desolder on the circuit board and replace them. But that's the relay that you need, and we do stock these at the website, but I do need confirmation what relay you're trying to replace, and I also need to know the leg configuration. This relay has 5 legs on it. I believe 2 are the feed and 3 are switching. But there you go. I'm going to insert this all back together, and then we'll do some basic tests on ampage on the machine. By the way, whenever you're reassembling these things, do clean off all the dust. As I say, I'm not being clinical in any way, shape or form. It's just dust does promote fire, and keeping these things clean do prolong the life. And you can see the amount of dust that's come out of this. Clipping the cover. Again, clean up the dust. Okay, we're now able to connect all the circuit board back up. Now the wiring onto the door switch. Make sure all the wires are properly on, and then we'll I'll just do this last connector. And I've got to make sure the wiring is tucked in and put the NTC sensor wires back on. Just replace these 3 screws for the top. So I'm very lucky that in my toolbox I've got a clamp-on meter. This will actually show me the ampage the machine is drawing while the machine is running. So I'm carefully just going to put this onto the positive wire and hold it here while I start the machine. And we can see that the machine is drawing 8.6 amps. And if you times that by the voltage, I'll have to work that out for you, but that should be drawing about just over 2 kilowatt of energy, which means the motor will be pulling something like 150 watts, and the heater is actually running basically 2000 watts. Thanks very much for watching this video. I hope you found the video helpful in understanding how the heating system worked on your tumble dryer. I hope the wiring diagrams were helpful for people with this type of machine. We went through the heating system, the thermostats, the relays on the circuit board. I have put links below and on the web page to the relevant videos to help you with the other faults. Do have a look at the relay video. I know it's slightly complicated for the normal DIYer, but if you've got a friend who can actually replace circuits and relays on printed circuit boards, you might be able to save yourself a small fortune rather than replacing the whole board. I hope you found this video helpful. Thanks very much indeed for watching.